Hello everyone and welcome back. My name is Mr. Cobalt, and in this video we're going to go over some practice problems on how to express your equilibrium constant for reactions. So here I got two examples. So the first example, we have CH3OH gas, and that is in equilibrium with carbon monoxide gas and hydrogen gas. And so we're going to form the expression of the equilibrium constant. And so remember, the expression of the equilibrium constant is the concentration of products over the reactants raised to their coefficients, raised to their powers that their coefficients are. So what does that mean? So let's start with our K. So our equilibrium constant K will be equal to, and we want the concentrations of products on top. So here's our line, okay? And so we have CO, carbon monoxide. It has a 1 coefficient, so it's going to be raised to the 1 power. So we're going to have concentration brackets, square brackets around CO. And so since the coefficient is a 1, then we don't really need to write the 1 there. So we just write CO, the concentration of CO in brackets. Then next is concentration of hydrogen. So we're going to put that in brackets. We're going to multiply that by the concentration of H2. And since there's a 2 coefficient there, that's going to be the power of 2. We're going to raise this to the power of 2. So we've got our 2 products down. And so the next thing is the reactants. So the reactants go on the bottom. We only have 1 reactant. So that's going to be CH3OH. That's our methanol. So we're going to put square brackets CH3OH. And again, since there's only a 1 coefficient here, then we're going to have a 1 raised to the 1 power. We don't write that down. So then this would be the equilibrium constant expression for this reaction. Okay, so what about number 2? Here we have the combustion of propane. So we got C3H8 gas reacting with oxygen gas, 5 moles of oxygen gas or 5 molecules of oxygen gas, and that's going to give us 3 molecules of carbon dioxide and 4 molecules of water or water vapor. Okay, so, and this is an equilibrium process, so remember the double arrows mean that you have a reverse and forward reaction. These are reversible reactions. And so again, to write the expression for the equilibrium constant is the same. So we're going to have K, we're going to write our K value down. So K is equal to, and then the products are put over the reactants. So here, our products is carbon dioxide and water. So we're going to put carbon dioxide down, So CO2 in brackets. So the coefficient here is a 3, so we're going to raise that to the 3rd power. So we're done with carbon dioxide. Now we do water, so we're going to multiply that by the concentration of water. So we're going to put concentration of water. Remember, that's in square brackets. So the square brackets means the concentration of, the molar concentration of. So this is a 4 coefficient, so we're going to raise this to the power of 4. Okay, so now we've got our products down. Now we're going to put our reactants on the bottom. So we have 1 C3H8, so we're going to put that down here. So C3H8. And this is a coefficient of 1, so we're at the raise this to the power of 1. We're not going to write down the 1 though. And we're going to multiply this by the concentration of oxygen. So we're going to put O2 down there. And then this is a coefficient of 5, so then we're going to raise this to the power of 5. So here's our 5. And that, ladies and gentlemen, is the expression for the equilibrium constant for this reaction. And it's that easy. So again, the equilibrium constant is just going to be the concentrations of products over the concentration of reactants, all of them raised to their coefficients as powers. I hope this was helpful and clear. And if you like this video, please like, share, subscribe to videos, hit the notification bell, and I'll see you next time.